Hey everyone, I'm Krishna from S6 CSB currently, and in fact, provided this video goes outside. I know the mic quality is a bit low because my earphones broke. Those were the best mics I had. I'm using the laptop's inbuilt one right now. So, I mean, last I checked, it's pretty good. So, hopefully, it's up to mark. Anyway, let's get to what we are gonna see today, right? Or rather, in this video, I'm here to talk to you, or rather, show you small two examples of pointers and their real uses, which is in functions. You may have seen pointers previously used for various stuff which may have not involved functions at all, and you may think that's pretty, that's why pointers made, but no, actually, of course, you may be confused. Pointers are not that relevant when they're not used in functions, right? I mean, you can use static variables. What's the difference? That's where that's where functions come in. Where there's a function, we need pointers to carry out some tasks, right? So yeah, let's get to it. I'm assuming you know how to do this highlighted stuff right here: declaration, definition, and allocation functions. Right. So let's move on to the first example here. So the use of pointers in functions mainly is so that whatever parameters you pass to the function and whatever the function does to those parameters, you want them reflected in the main function, right? Of course, you can have static variables in the main function which pass their values only to the function through parameters, and have the function do stuff and return a specific value back to the main function, which may have very little to do with the actual variables that you passed as parameters. That's, of course, that's there. But there are certain cases where you want parameters to change too, according to what happens in function. Right. So I'll explain about this later, the use case of this later. For now, let's see how functions and pointers work together. So the first example obviously is hello world. I mean, come on, you've seen this before, but this is like actual hello world, right? Yeah, I misspelled hello world. Forgive me for that. It's not relevant anyway. So here, what I've done is I've made a function called mute string, right? Mute string. It's just to change the value of of the string passed into the function. So what it does is this is the string pointer that we received from the main function, and we are just giving a different string onto it, not the same string as the main function given at first. You may have not seen this function sprintf, which is basically the same as printf, right? Which means you can print a string to std out, right? Std out, standard output buffer, or the standard output console, which is the output at the terminal. Yeah. What sprintf does is it outputs a string. This is analogous to this part here. Outputs that string into the specified string pointer. Yes, this looks pretty confusing because I have used the same variables here and here, but no, look at it instead as just variables and not the names of the variables, right? So this is the string that we're gonna output to where, not to std out, to here, to this string, this particular string pointer. That's what sprintf does. All right. Yeah. So what this does is it shows you how pointer parameters passed through functions are reflected back in the main function. Alright, so first we have this declaration, then we have this where we define the content of the string. Here we print the string, and here we call a function which changes the string, and then we print the string again. Alright, so I've already compiled the the file here, so all I need to do is see, we are using the same pointer here, but here it's a different name. But what we understand is that whatever changes to the content of this pointer was reflected in the main function also. So in essence, this is almost like same as this, except we know those are different variables. And yeah, this, you can say that this is like passing by reference, right? Yeah, so this is a good way of showing you how the changes made in the function reflects back in the main function from which the function is called, right? Yeah, so let's get to the second part of uses of pointers here, right? So yeah, so what I've done till now is to just show you how functions and pointers work. Now let's get to the actual use case here, right? This is a small program which sorts this array using quicksort. Yes, quicksort, qsort. I have not defined qsort here. Yes, qsort is a predefined function in stdlib. Yes, this is C language. You're not looking at C++. Can you believe that? I know. Anyway, let's get back to what we are actually doing here. Yeah. So this is the array we have here, and we have these values here. Num is the size of the array. Width is the size of each element of the array, and I is, you know, iterating variable. Yeah. So here you may say void star. What's void star? Welcome to the real world of pointers, my friends. Void star, that's the main used pointers, type of pointer anywhere you go. Void star is a general purpose pointer. That's all it is. I'm just exaggerating here, maybe, but no, yeah. So what void star does is let's say you have an array such as this, right? And if you define an integral pointer here, which is int star ar equals ampersand arr, what that gives you would be an integer pointer, right? So in essence, this integer pointer ar points to the first element of the array, as you may know, right? It's obvious, yeah. And we can work with this by referencing second element in the array, or rather the first element in the array according to indexing. We can do ar plus 1, ar plus 2 for the second element, ar plus 3 for the third element, and so on, right? But here, so what a void pointer is once you define a void pointer here, void star ar equals ampersand arr, this here won't work. This is called pointer arithmetic, right? This won't work. No, this won't work because void pointer points to the whole array, as in it is just a pointer that's pointing to the first byte of this value right here. And if you were to do this, you won't be referencing the second element in the array, or rather first element in the array according to index. No, you would be referencing the immediate next byte, which is pretty useless in at least the current logic we are using, right? I mean, there are uses, of course, but let's not get into that. Our current logic here is to reference this array, but no, we can't do that with void pointers like this. So that's what a void pointer is. It's a totally general purpose pointer. You can, of course, use CLOC and MLOC the same way as normal, but it's just that you can't use a pointer arithmetic. That's what a void pointer is. Now, here qsort uses a void pointer. Obviously, qsort, people who made this inbuilt function called qsort, obviously they provided for arrays which are not necessarily exclusively integer arrays. See what I'm saying? I mean, of course, it's pretty simple to sort integer arrays, but we know sometimes we want to sort, let's say, strings in dictionary order. What are you going to do? So, to provide for that, they made qsort using a void pointer as a parameter, which takes the whole array as a void pointer, and this is the number. The num means like the size of the array. That is how many elements in the array. Width is the size of each element in the array. And compare. Yeah, this is where things get a bit, complex. Not necessarily complex, but yeah. So what compare is of course I've defined the function compare here. So this parameter takes a function as a parameter. This is a function parameter. What it does is to compare between each element while sorting, it uses this function. It passes the two values into this function and receives the return value, checks if it's 0 for success, checks if it's 0, -1 or 1, right? And if it's 0 or 1, it's okay. It does what it does. It sorts properly, as in let's say if the number is bigger than, or if element 1 is bigger than element 2, it places element 1 bigger before element 2, right? But if it's the other way around, it receives a -1, which means no, you can't do that. So it does the opposite, place element 2 before element 1. So that's what qsort does. Qsort actually takes function as a parameter. Yeah, it's pretty hard to understand, I guess, but you can work with this. There are a lot of inbuilt functions in C. I know you're surprised, me too. Yeah, so that's what qsort does, and this here is the main use of pointers. Now here also in compare function, const void lm1, const void star lm2. Here also it's a necessity of qsort to let the compare function, or the function that's passed here, to have void pointers as parameters, because obviously this is not specific, right? This is not specific to let's say integers or even strings. This can be literally anything. It can be even structures. right? So void pointers are capable of handling multitudes of types or data types. In fact, multitudes of data types at the same time, which is a different, which is a more complex topic that I'm not going to go into in this video. But you may see a further video on this anyway. Yeah, so this is not restricted to any specific data type, and only void pointers are capable of handling multitudes of data types. So even here also we need void pointers as parameters too. You get it? But the return type is of course integer, because that's what qsort requires of it. Anyway, so what it does is it now, of course, we want whatever happened in qsort to reflect back into our main function, that's arr here, right? It happens, it will do so because we used a void pointer to pass the array into qsort function. Let's see what the output is. Okay, I've already compiled this once, so I'm not going to do it again. I'm just going to run the object file, see what happens. Boom, it's sorted in ascending order. Isn't that what we want? Yes. So this is the actual main use of pointers. It's pretty cool, right? Yeah, it is. It's pretty hard, looks pretty hard too, but trust me, it's not. Once you get used to programming like this, right? It's same as it's same as functions when they were first introduced to you, right? That's all for this video. Hope you enjoyed the content. I'm sure you have a lot of doubts, want to explore more of this, but yeah, it's a pretty complex topic, so you're gonna have to look it up yourself. Okay, that's all for this video then. Have a great day, guys. Keep working on this. It's a pretty good use of pointers, and you can do hell of a lot of stuff here with this, right? So see you guys.